This webcast continues discussing the lab, which is looking at energy transfer from gravitational to kinetic energy. And I'm at step 19. So when we finished the previous webcast, we were getting data. And so now I have my 8 data points here. And the first thing that I want to do is to put a copy of my data table from Microsoft Excel into my lab report. And so I'm just going to copy my, highlight my table, do a Control-C, come over to the lab report and paste that in. So here, that didn't work very well. Let me look at that again. I'm going to do a paste special. So I'm going to go Home, Paste, Special, and let's do an enhanced meta file. I think that would be the best. Yes, look at that. It fits it to the width of my page. So that was the best way to paste it. Okay, so I've showing all of my 8 data points. And then it says, let's make a graph. I'm in step 20. I want to do a graph of the initial gravitational potential energy at the top of the ramp versus the speed at the bottom of the ramp. So that means that on the x-axis, I want to put the speed at the bottom of the ramp. And on the y-axis, I'm going to put the initial gravitational potential energy. Okay? So if you look at your Excel file, these 2 columns are not next to each other. The initial gravitational potential energy, this is going to be my dependent variable, because that's going to go on the y-axis. The speed at the bottom of the ramp is going to be my independent variable, because that's going to be on the x-axis. I know that because of the way that they've labeled the graph, right? Initial gravitational energy versus the speed at the bottom of the ramp. Okay? Because it's always, what's on the y-axis versus what's on the x-axis. Okay, so since those 2 columns are not next to each other, and they're also in the wrong order, this is my x-axis and this is my y-axis, I'm just going to copy these values so that I can put them next to each other. So I'm going to copy the values of the speed at the top of the ramp, speed at the bottom of the ramp. Those were not formulas, they were just typed, so I can simply copy them and paste them over here to the right. And then but the gravitational potential energy at the top of the ramp, that was a calculated field. Remember, we put a formula there. So I'm going to copy these, but I have to do, and I'm going to paste them to the right of the speed column, because this is on the y-axis. I can't just paste them because of all those addresses and references in the formula. So again, I have to go to do a paste special, and I want to just paste the values. Okay, so now I have the values that I want on the x-axis and the values that I want on the y-axis next to each other. And so now I can just highlight, select these numbers and do an insert of a scatter plot. There we go. Okay. And so this is, the initial gravitational potential energy at the top of ramp versus the speed at the bottom of the ramp. Okay? And we also need axis titles. So that's speed in meters per second. And this is gravitational energy in joules. Okay. I have an extra character there. There we go. Okay. So if you look at this graph, you might think that it is linear. And, you know, not knowing anything else, we might think that. Actually, I'm going to go ahead and grab a copy of this and put it in the lab report here at step 20. Okay, but actually, and it says this here in step 21, it's not linear. You know, the simulation tool really constrained the range of heights that you could use, and therefore we weren't really able to get the range that would have helped us see the curve of this graph if we had more data points. But it is actually what we're looking at is part of a quadratic function. It's curved and it looks like a parabola, okay? And so we need to linearize this before we write a physics equation for it. And so we're going to create a graph of the gravitational potential energy at the top of the ramp versus the square of the skater's speed at the bottom of the ramp. Okay, so I'm going to go back to Excel, and you could copy that table, and now you truly can just copy if you want, because we don't have any formulas there. We pasted all of those as values. But I'm going to change this. Instead of speed at bottom of the ramp, I'm going to say the square of the speed at the bottom of the ramp, and it's going to become meters squared over seconds squared as units. Okay, but I'm not going to do anything to the gravitational potential energy. We're not changing those values at all. I'm just going to go ahead and delete those values because we have to change them to become the square of the speed. Okay, so we're going to use a formula in Excel to calculate the square of the speed for us. So in that top row, I'm going to say equal to start a formula. I come over and click in the cell that has the first value of speed. Come up to the formula bar, do Shift 6 to get the caret, and type 2 because we're raising the speed to the power of 2. Hit the enter key. Okay, so 12.25 squared is 150. You could type that in your calculator if you want to double check, validate this formula. Once you have the formula working, you can just copy that formula down the length of that column. So now I have a table which has the square of the speed and the gravitational potential energy at the top of the ramp. Okay, so I'm going to make another graph, and let's see if we get a nice linear graph here. That's what we're hoping for. Well, so I'm going to highlight these numbers and insert a scatter plot. And it is now it is truly linear. Okay, so this is going to be the gravitational potential energy at the top of the ramp versus the square of the speed at the bottom of the ramp. Okay, and so this is square of speed, meters squared over seconds squared, and this is the gravitational potential energy in joules. Okay. For this graph, you need to copy not only the graph but also the data table, okay, because we don't have that anywhere else in the lab report. Copy that and paste that in the report here at step 22. Once again, I did that. I need to paste it. It would look better if you paste it as a meta file, because then it will automatically resize for you. There we go. Okay. And so then we want to give the value of the slope, including the units. You can just use any 2 points in this table to calculate your slope. You could also ask it to do a trend line, where you ask it to do a linear trend and show you the equation. Let me see if I can find that, where it says display the equation on the chart. If you do that, it gives you the slope there. Okay, of course you'll have to figure out the units, but if I look at my graph, I can see that the slope, I would calculate it as a change in what's on the y-axis divided by a change of what's on the x-axis. So be 30.965. For me, this is 30.965. It would be joules over meters squared per second squared. Then you'll need to write a physics equation, and you can ignore the y-intercept. Remember that here the independent variable is the velocity squared. The dependent variable is the gravitational potential energy. Okay, let's simplify these units. So we have joules over meter squared over second squared. A joule is a Newton meter. A Newton is a kilogram multiplied by a meter per second squared. So here I'm going to have kilogram times meter squared per second squared. And so the meter squared per second squared cancel. I have them both in the numerator and the denominator. And so these units, as ugly as they were, they just simplify to be something very nice and simple. They're just units of kilograms. And if we, were to put several teams' results here using different constants, for different values of the mass of the skater. So I had the mass of the skater was 60, and my slope was 30.965. And you'll find that for every team, the slope of the gravitational potential energy versus square of speed is approximately equal to half of the mass of the skater. And so we can probably conclude that here. We would say that, several teams, completed this experiment using different values for the mass of the skater. In all cases, the slope of the graph of gravitational potential energy at the top of the ramp versus the square of the speed at the bottom of the ramp had a value which was very similar to half of the skater's mass. And there's data for that at step 26, right, where we have that table summarizing that. But we have more evidence for this. So also the units of the slope simplified to be units of kilograms, which is the unit of measure for mass. So the units simplify to be the units that we would use to measure mass, and the value of the slope resembled half of the mass. So therefore, we conclude that the slope of the EG versus the square of speed graph has a physical meaning, which is half of the skater's mass. Okay, so that would be, kind of what we can conclude about what this slope really means. So therefore, we can rewrite, I'm going all the way down to step 30, we can rewrite our physics equation. We had something that was gravitational energy is some slope multiplied by the square of the velocity. Well, in place of that slope, I'm going to put what it means, which is 1/2 of the mass. And so we get a relationship here. Gravitational energy equals 1/2 of the mass times the velocity squared. Oh, and I do want to change, let me not forget to do that, change, oh, it's not working. Sorry, let's see here, let me get an eraser. Okay, it says change, Well, I was trying to highlight here where it says change the gravitational potential energy to kinetic energy to recognize that the initial gravitational energy at the top of the ramp was transferred to the skater's kinetic energy. So this relationship right here is a general model for how to calculate the kinetic energy of the skater. The kinetic energy is 1/2 of the skater's mass multiplied by the square of the velocity.